The pulp and paper industry is one of the largest industry sectors in the world and a significant contributor to global wastewater pollution. The wastewater generator is characterized by a complete mixture of organic and inorganic substances including chlorinated compound and suspended solid. These pollutants result in high chemical oxygen demand (COD), color and pH fluctuation which pose a serious challenge for conventional wastewater treatment system. If not adequately treated, pulp and paper wastewater can lead to severe environmental degradation including aquatic toxicity and long-term ecosystem imbalance. In addition, this issue requires a combination of physical, chemical and biological treatment technologies tailored to the specific contaminant present in the effluent.
Layout of the plant. The layout of a typical pulp and paper wastewater treatment plant includes several key components: an equalization tank, a primary clarifier, an aeration basin for biological treatment, a secondary clarifier, a tertiary treatment unit such as filtration and chemical oxidation, and sludge handling units. The plant is designed to handle high volumes of wastewater with significant organic and chemical loads. Process flow. The first step in process flow is equalization tank. This tank stabilizes the flow and pH of incoming wastewater and mix water from different sources within the plant to provide a uniform quality before further treatment. The function is to stabilize the flow rate and pH of incoming wastewater before it enters the treatment system. Next, the primary treatment. Primary treatment is involved sedimentation in the primary clarifier to remove larger suspended solids and floating debris. The main unit is primary clarifier, and the function is to remove suspended solids and floating material such as wood fibers and coarse organic matter.
For the secondary treatment, this step includes biological degradation using systems like activated sludge process. Microorganisms break down organic matter in aerated conditions. Function to biologically degrade the soft and fine organic matter using microorganisms. Next, tertiary treatment. Advanced treatment methods such as chemical oxidation and filtration are used to remove color and residual pollutants. Function to further polish the effluent before discharge of the environment. Next, sludge handling. Sludge from early stage is thickened, dewatered and treated. It may be reused for energy recovery or safety disposed of. Function to process and dispose of the sludge generated from primary and secondary treatment. Typical steps: first, thickening, reducing sludge volume by removing excess water. Next, dewatering, using bed press or centrifuge to further reduce moisture content. Next, stabilization or composting, biological treatment of sludge to reduce pathogens and odor. Final step, final disposal or reuse. Treated sludge may be landfill, incinerated or reused for energy recovery or as soil conditioning.
To talk about my point, which is influent and effluent properties. So this slide shows the difference between the influent, which is the raw pulp and paper wastewater, and the effluent, which is the treated water after going through the treatment process. First, the pH and the raw wastewater can be quite extreme, between 4 to 10, but after treatment it can become more neutral around 6.5 to 8.5. COD and BOD are very high in influence. COD is 2000 to 5000 mg per liter and BOD is 1000 to 3000 mg per liter. These numbers show how polluted the water is after treatment. Both are reduced a lot. COD becomes less than 2.250, BOD drops less than 100. The color of raw wastewater is usually very dark, but after treatment it becomes much clearer and or lighter. And lastly, there are many suspended solids like fibers and bark in the effluent, but they are mostly removed, so the effluent has very low solids. And so this shows how effective the treatment process is in cleaning up pulp and paper wastewater before it released.
The treated effluent comply with Malaysia Standard B, discharge limit set by Department of Environment (DOE). Key parameters such as pH, COD, BOD and suspended solid are within acceptable limit. This ensures the final discharge is environmentally safe and may also be reused within the facility where applicable. In conclusion, pulp and paper wastewater contain harmful pollutants that can impact water quality and aquatic life. Effective treatment and cleaner production practice, including recycling, are essential for environmental protection and industry compliance. That's all. Thank you.